surface tension, viscosity, and capillary action. In this video, we will be describing these three concepts. These concepts' our main applicability tends to be in biology and physics classes. However, the underlying principles to these are intermolecular forces. It's important to talk about them here in this context of a chemistry class so that you can better understand them in your biology and physics context where the topics are more often used. Surface tension happens because intermolecular forces of molecules at the surface are using more of its attractive forces to attract less molecules. This creates more tension at the surfaces of substances than within them. So things like water bugs can use this to skate across the water, so long as their mass is spread out over a large enough surface area. You can see that this might be why the water bugs have a very large portion of their legs on the water. Of course, molecules that have higher intermolecular forces will also have higher surface tension, given the stronger attractions. In the figure here, I've tried to diagram how this would work. If you look at the top molecule, it's using all of its intermolecular forces to attract 3 molecules. Meanwhile, a molecule that's further into the surface is using its intermolecular forces to attract 6 different atoms or molecules. So this means that at the surface there is more tension, or the molecules are being held together tighter. Viscosity is the resistance of a liquid to flow. Since we are pretty adapted to think of water as free-flowing, I use this as my example of a low viscosity liquid. But actually, in comparison to a lot of things, it too is pretty high. However, let's compare it to something like honey. Honey is definitely a liquid at room temperature. It flows to the shape of its container and has a defined volume. However, it flows very, very slowly in comparison to something like water. This is because it is what we call viscous. The more intermolecular forces that a liquid has, the more that the molecules are held together, and so the higher the viscosity and the less free-flowing it is. Temperature also impacts this. If you increase the temperature of a substance, it will lose viscosity. It will flow easier. And you know this if you've ever heated up honey for tea, because it gets more runny as you warm it up. Now our last one, capillary action. Capillary action is a bit more complicated than the other two. There are actually 2 competing forces that lead to the capillary action. The first involves the intermolecular forces within the liquid. These are called cohesive forces and hold the liquid together. The second is the intermolecular forces between the liquid and the walls of the tube that the liquid is in. These are called adhesive forces. So if you put if you put liquid inside a tube, it may or may not flow up the tube. And the amount that it flows up the tube is different based on the substance. If cohesive forces dominate, or in other words, the forces that are holding the liquid to itself dominate, then there is very little capillary action. However, if adhesive forces dominate, or in other words, the interactions between the walls and the liquid dominate, then there is a lot of capillary action. For a quick review, liquids tend to attract each other, minimizing surface area. The higher the IMFs are, the higher the surface tension is. Viscosity is the resistance of a liquid to flow. The higher the IMFs, the higher the viscosity. Capillary action is the ability of a liquid to flow against gravity in a narrow tube. If you have higher cohesive than adhesive forces, then you will not have as much capillary action. Meanwhile, if you have higher adhesive forces and lower cohesive forces, then you will get more capillary action.